So, coming back, we were talking about randomized complete block design RCBD, okay, where now the data is arranged in matrix. Earlier the rows had meaning, the columns did not have meaning, the rows had treatments at various levels. Now the columns are blocks at various levels, okay. So there are A treatments, B blocks, A levels of treatment and B level of blocks, okay. Treatment as a single factor, still it is a one factor ANOVA, meaning there is only one variable of interest, okay. So that is why it is treatment is a factor, and that factor is at various levels, like dosage is a factor which you are interested in, that is one factor, and at various levels. So the A levels are the treatment levels, and now we are interested in blocking one more variable. Your interested variable is one, you are not interested in one factor, which is what we call it as block, and we want to block the effect on the output. Why do we need to do blocking? Why should I not do just ANOVA everywhere, close my eyes and do ANOVA? Why should I block a particular factor? What will change in your results? If I do ANOVA instead of a RCBD, why should I first learn RCBD? Why not do ANOVA only? You understand, right? Now what are we interested? We are interested in A treatment levels, but apart, this is all fixed effects model. Apart from that, I am going to block the effect of another variable, okay, nuisance variable or noise variable or nuisance variable. Why should I worry about that? Why should I not do ANOVA directly? But what does it help? How does it help? Yes, I understand it is not of relevance, but it still affects your output. So how does it help finally? Where it should have an impact on the hypothesis testing. All we are doing is hypothesis testing. Remember, we are saying at least one treatment is not equal to 0, it has an impact. How does it help in proving my hypothesis? You all understand my question? This is all finally towards hypothesis testing, where my null hypothesis is all treatments are equal to 0, alternate is at least one not equal to 0. Now blocking, how does it help in hypothesis testing? What is the impact of blocking? Why should I do a blocking? Why not do just ANOVA for everything? What will change? Huh? Degree of freedom will reduce right here. In fact, it will be opposite. For I will have totally A into so the noise is A into n minus 1 and the treatment is A minus 1. Now I will have blocks also. So B minus 1 will be gone for blocks also. So it is actually not going to help. It will reduce the treatment degrees of freedom in a sense. Treatment is A minus 1 only, right? And blocks, now I am introducing new one. So that is not going to help. Treatment, it is not the degrees of freedom. What else? So what is my F test? What is my F test on ANOVA? Mean square treatment by mean squared error. Now if I do not do blocking, mean squared error will be composed of what? Mean squared error will be composed of noise and nuisance. So noise plus nuisance will become the mean squared error. MSE will be composed of two components now, which is noise plus your blocking variable, right? Your variable, irrelevant variable which affects your output. Now mean squared error will go high. So your hypothesis testing actually will, even though if your treatment may be good, your treatment may have an effect, but when you do hypothesis testing it will not come out. Why? The denominator will increase. So your mean squared error is now will be a function of both. If you do just ANOVA for this case, your mean squared error will be both due to noise and nuisance factor. So mean squared error will increase. If your mean squared error increases, obviously your ratio, your mean square treatment to be has to be really large enough to show that it is working. You understand? So that is where the challenge is. So even though if your treatment may be good, you will not be able to prove that because your mean squared error becomes larger. Okay. So if I know gender is an impact and this is supposed to work on, let us say the target audience is for older people, and if I include some age without considering age, I have included all age groups, what will happen? Obviously it will not work for younger groups, let us say, because the target audience is older, but you have considered younger people in your studies. So now what will it show? It will show that it is not working for, it is not working, basically the results will show. But why is it not working? Because you have included younger people in the study, which you should have discarded, or you should have at least blocked its effect and then say for this age group it is not working, this age group it is working. But if you do not consider, then overall your treatment it will appeal that the treatment has no effect, although there is an effect. So that is why blocking becomes very essential in order to prove your or disprove your null hypothesis. Okay, blocking is very essential, because if you do not block, if you know that there is an irrelevant variable, and if you do not block, mean squared error is going to increase. Okay. So that is the reason why we have to do blocking. Make sense?